1, 2, 1, 2, 1, 2, 1, 2.
The broadcast is now starting. All attendees are in listen-only mode.
Good morning and welcome to SolidCAM UK's webinar on HSS. My name's Ronnie Smart and I'll be showing you around this module this morning. On screen we have two very similar parts. In fact, they're created from exactly the same geometry. One's been created as a male and the other as a female. These may be two parts of a mould. In this case, the dimensions are identical. We don't need to worry too much about shrinkage or anything like that. We're only here to show you how the module can be used. So the one that I'm going to be working with first is the one on the right, the male. So I'll minimize this one for the moment and bring this one up to full screen. Now, HSS is designed to work on individual or multiple surfaces. As you can see from this shape, because I have the solid with line shaped with edges on, we can see each of the constituent surfaces. And man, are these awkward. There is nothing about these that is regular or would be cooperating with most people in any way, shape or form. So we've got little horrors in here that hide away between two pieces. We've got near vertical faces here which are curved and changing shape down to this transition point here. So, how are we going to cope with this? Well, first of all, we would rough out the stock down to leave possibly 1, 2, 3 millimeter on this. I have used the HSS function here, and I'm sort of jumping ahead here. I've prepared this sort of Blue Peter method so we can quickly get to the finishing point. However, there are some points of note here. In this case, I have used roughing and more and selected depth cuts to allow me several cuts to come down in to leave the surface exposed. In other modules, this would normally be paired with the HSR module, and the HSR module would do much the same thing, but in some cases it's just as quick, just as handy to use the HSR and use some of the functionality in here to rough it out. So we'll simulate this and we'll do it in Solid Verify so you can actually see what's happening. So there's our stock block. I'll slow it down a wee tad and run it. Now that, in this case, the reason that the crash has come in is that I have not set any appropriate, shall we say, clearance. And because this actually morphs or stays constant to the surface it's on, it's unpredictable as to how much it would plunge. If I had taken another cut of 3 millimeter, you would have possibly seen it clear that without any problems. So that's something to note. There are ways round about it, but as I say, normally you would use an HSR function to take this out. What you're seeing there, and what's not visible, is the fact that this follows the surface. It just basically lifts the whole cut set up. So there will be air cutting. There's no attempt in this to, shall we say, optimize the cut. It simply repeats itself with the appropriate step. So we'll see it again, it will come back and it will take the next cut, which is down by 3 millimeters. I think I set it for 3 cuts of 3 millimeters. I don't know if everybody can see this too well. Let's change it and see if that helps. Change it into the plane mode, and you can see how the cutter is working its way over the shape. Now the other thing you'll notice here is that I've used a straightforward end mill 12 mil end mill, no special characteristics, and yet it's taken this out without too much problem. You can see the depth of cut clearly as it comes up, as it's beginning to rise now. Now as for a regular toolpath, this toolpath will move and twist and turn to meet the shape. In general, it has been set to work along the y-axis, but as the tool moves over, shall we say, to accommodate the shape of the surface and to allow us to get the edges, it deviates a bit. But that's all quite normal, and that's part of the functionality. So we'll just speed this up a little bit. So I think you'll agree we have a fairly good representation of the surface. We have a couple of mil left on the surface there. If I show the target and put it into wireframe mode, you can just see the target underneath it there. It's not the best way to see it, but so we have our piece roughed out. The next part we're going to look at is a number of different ways that we can actually machine this shape and how we can change things to make the toolpath more efficient. What we've got here is another HSS. Now I've used a bullnose cutter this time. It's a 10 with a 2 mil 0.5 rad. Let me check that. Second cutter here is this time is a 10 with a 0.5 rad. Now one of the problems that I've come across in programming over the years is when you get a crease like this. A designer has put in an edge like that, and you've got to try and get that to as near as sharp and crisp as possible. Sometimes you can do it, sometimes the restrictions on other parts of the part just don't allow you to do it. However, here, this first method that we're going to use here is taking will actually give us a 0.5 radius in the sharp corner there. It'll also allow the tool to work tangentially on the radius on the of the cutter, and perhaps give us a slightly better surface than it would if we were just going straight backwards and forwards with a square cutter. The next stage will be to do exactly the same with the ball-ended cutter, fully ball-ended 6 mil, but the 6 mil will obviously leave radii in or a fillet round about this edge, so we would have to come back in with the smaller tools and finish that anyway, which is not a great problem. You will see at the present moment that there's a lot of air cuts and retractions from the surface here. It's moving over every time. One of the functions that's available in HSS is the ability to link these cuts. So we can choose on this page to use a lead-in, which could be helical, tangential, circular. And on this page we can quote for any gaps or step overs. So by simply saying small moves here and saying follow the surface, which will mean that if there's a gap, and at the present moment it's set for 110% of the step over. Now the step over here is about 0.25. I'm going to exaggerate this and I'm going to take that up to 2 millimeters. I'm going to save and calculate, and let's see how this changes the structure of the toolpath. It has reduced the step over, the amount of air cuts in some places, and it's pretty good this, because you can see here exactly where it has started to open up. Now, what's wrong with this picture? Let's put it into wireframe, and we can see, now we can see the transitions between the two. So why is that? Is it actually digging into the surface? Well, again, we have the facility here to, excuse me, let me hit the right button, to gouge check and make sure that we actually are going to avoid digging into any adjacent surfaces. So I've come on to the gouge check here, and I've told it to check first of all the drive surfaces, the working surfaces that we're on, but now I'm also going to add these flats on either side, and then we're going to check the direction of these. It's a habit I've discovered over the years, better to check and see the difference. The HSS module and the 5-axis simultaneous module are very, very similar. On the 3-axis, as we are here, then it doesn't really matter too much. The tool will stay on the top. But on the 5-axis, it would try, if the direction of the surfaces was the wrong way, it would try to put it on the underside. So let's now save and calculate this. We've told it to retract along the tool axis if it comes in contact with any of the checked surfaces. And that's what these two settings here are. Now, if we look now, we can see that we now have the join between consecutive paths is actually visible on the surface. It's no longer going that bit deeper. Now, in some cases, you may wish to open up the link to try and take away some of this. There are ways that you can do that. For the moment, we're just going to accept that we've reduced it substantially. We could go on and chase it down until we get very, very little. However, you will notice that the toolpath in certain areas is better than others. Along this face, we have a nice close 2.25mm step over. In this area in the center here, it begins to lose it a bit. Likewise in here and along this side in two areas, and along this side in two areas. This is a linear parallel cut, so it will be following the direction along this side. So basically what we're doing is we're slicing it in this direction. Now, that's toolpath may be very good in some cases. In this case, as we can see, and again, what I'll do just now is I'll run the solid verification, and we'll put it full up just so we can get the thing there quickly. And again, I'm going to ignore that and say go for it. Now remember, we left 3mm on the surface, and that you can see is clearly reflected on the flats at the side. Okay, so there's our surface, and if we zoom in, you'll see that we have our nice 0.25mm step over. But on the side, on the left hand side here, and on the right hand side in this cusp, and on this bump area here, it's not so good. It's a bit guffy, in fact. But as a first pass or a semi-finished pass, it is quite acceptable. Okay, so let's look at ways of improving that. So we'll leave that toolpath in there and just accept that that toolpath is going to be our semi-finish. In fact, I'll go in and I'll add on 0.25mm onto it. On the geometry page, we can add the drives offset 0.25. So we've still got a finishing allowance left on this surface. As you can see here, we can define the angle. Quickly, once this is finished, I'll change the angle and reprocess it again. Now I'm going to change the angle to 45. Save and calculate, and let's see how this performs this time. Sometimes it's just a case of turning it round that little bit. Many toolpath toolmakers will finish these paths at 45 degrees. They believe it gives them a better finish, and in most cases they're correct. So Again, we'll probably get the crash here. I'm not too worried about that because it's just down to my settings and the way I've done it. And you'll see now that we're working at 45 degrees. We'll have a look at this with the raw toolpath mode shortly just to see how the toolpath differs. Okay, that actually looks a bit better. We still have this area on the left hand side here, but you will notice it's moved round. It's smoothed out some of the roughness that was in this area here in the open area, and it's smoothed out some of the roughness along here. So all in all, not too bad. Right, but we still have 0.25 on the surface. So what I'm going to do now is to use the trick that most of the experienced people with SolidCAM do, is we just save and copy, because we're going to do a similar HSS operation, and I'm only going to change what I need to change. So I'm going to change to morph between two adjacent surfaces. Now let's have a look at our geometry, and we'll show the geometry that we've picked. Now that is exactly the same. I haven't changed anything there. We're going to work on the same pieces, so that's fine. I don't need to change that. However, I do need to add on the surfaces that are going to be the guides. So we'll click and we'll put this one on for our start edge, and our end edge will be this one. Okay, so now my drive offset I'm going to put down to 0. We'll put it down to 0. The tool that I'm going to use this time, we'll use the same tool and see what happens. Save and calculate, and now it's calculating on exactly the same amount of it's more or less the same parameters as it was before. However, now we have changed the way that we're doing it. It's still using the same gouge checking, it's still using the same step over. Now let's have a look and see what it's done here. Now this time I'm just going to go for the plain one with Solid Verify, because we get both the verification, and you'll see that our tool path is now running along the side, parallel to the side, and it will work its way over. Now this will take exactly the same number of cuts all the way along the body from start to end. So if we have 0.25 at this bell end, there will be the same number of cuts at the small bell end. And as you can see, it's, as it says, it's morphing over the top of the surface. There is an area in there that we might need to come back and redress. That's not a problem. We'll do this again with a ball-ended tool and see the difference in an effect there. This mode is quite good because we have the verification of the model. We also have the toolpath, so we can see the center line of the tool, or the touch point of the tool, whichever way it's set, and we can see the stock being machined away. On a small step over like this, it takes a wee while to run the path. So let's just stop that at the moment, and we'll use the quick Solid Verify, and we'll run this quickly. It's not taken into account the operations from beforehand. As you see, it's also not caused a problem. So we'll let this run, and we'll see what the quality of the surface is. Now remember, in relation to the actual curves and surface curvature that we're working with, this is a pretty big chunky tool. It's 10 mil, it has a 1/2 mil radius. We may have been more appropriate to use a smaller tool, or even to use a square tool. It just depends on a lot on the way that your particular shop decides to do things. We all have working conventions, and they differ. They sometimes differ between two places in the same organization, let alone two different organizations. So we'll put that set to single color. We'll take that off, and then we'll get the colored by tool. This will finish in a few seconds, and we'll look at the next bit of it. This is not a particularly big block. If I remember correctly, the dimensions, it's only about 100 mil long and 50 mil wide. So we're not talking about a huge part here. Right. Avoid time. Let's take a closer look at the surface here. And we'll zoom in. It will be a bit pixelated because of the way that this particular module works. But I believe you can see that in most places this is pretty damn good finish. And if we'd left it go, we would have got our shape with a minimum of radii in the corner. Now that's two methods of doing it. Now I'm going to suppress these two here. In fact, I'm only going to suppress the last one. Go back into the one that we did previously. In this case, I'm now going to change it, and I'm going to select the 6mm ball end. Select that, and for speed, I'm going to change my toolpath step over here to 0.5. Save and calculate, and we'll have a quick look at the simulation in that. The actual scallop is shown here, so you can see from this little icon down there, the scallop height here would only be 10 microns at 0.5 with this tool. If I chose a different tool, that would, the ratio there would be different, but this is the surface quality that you're going to manage to achieve with that setup. Now let's let her go. As I say, we're now going to be a bit rougher, but for the purpose of what I want to show next, then it's ideal. Again, you can see with the settings here there are areas where it has lifted and dropped. We can change the character of that and even take it out completely in some places. Now, Now that our friend here has finished, let's take a look in at this area in here. And you'll see that we now have this 3mm fillet along the sides. Well, we've got pretty good finish across the top there. The ball-ended tool takes up, and that's quite acceptable. So how can we sort out this edge? Well, I'm going to go in extreme here. I'm going to save and copy. This time I'm going to choose the square tool. Again, in fact, I'm going to add a new 6mm square tool. I'm not going to bother about feeds and speeds because this is only a demonstration. And in my geometry, I'm going to choose specific faces. So we're going to take in this and this. We'll take in that one and then that little one there. In fact, we can take the top one as well. You'll see why in a second, why it doesn't matter too much. Again, let's just check to see the direction. That's fine, everything's coming out the way. Take that off. So, this time I'm going to choose parallel to surface. And in the geometry you'll now see that my edge surface is required, so I choose this surface. And now in here I have determined by number of cuts. So I can switch this on, and if I've got one cut on there, and I save and calculate this and then just simply simulate it. Excuse me, I'm going to take the verification off so it doesn't get in my way, and you'll see that we've got one cut along the edge there. If I change this now to say 10 cuts, cut tolerance, maximum step over, and I'm going to take down to 0.15. In the gouge check, I'm going to leave it as it is, but this time I'm going to say trim and relink. I don't want it to lift the tool up. And when I run it now, you can see that in most of the areas here, it has actually cut along the bottom. So if I put that into Solid Verify, and we run it, now you can see that we have taken this down to a nice sharp crisp edge. I think I know what's wrong there. Check surfaces, drive surfaces, take that off, and enable. We'll pick that, just slightly changing the way that this works. I haven't run this path before, and usually I might have 2 or 3 different tries at getting the just exactly the way I want it before I put it to the finish. Now for some reason on all these toolpaths you'll have noticed there's an area in here where it seems to not want to machine. If I take off the change that to check surfaces, check which one that was face 7. We'll take that to face 7 and we'll take that one off. And you'll see now we get that smooth transition along the bottom, and it follows the surface up the way. Now let's see which way this is going. Is it coming from the top down or the bottom up? In actual fact, this one's working its way down from the top. That's fine. That's exactly the way I wanted it. But sometimes, depending on one factor or the other, it may work the other way. So I can come in here and let's say that I wanted to start from the bottom and work up the surface. We haven't got much material to worry about, so if I go into the Solid Verify again, this time when we look at it, we can run it, and we're going fairly slow here. And you can see that in this case we've got a cut around the actual finished edge, and it's now working its way up the surface. We would have to come up a bit further. I only took 0.15, that's 10 cuts, that's 1.5 millimeters. We've got a 3 millimeter radius in there. I'll just change it to change the number of cuts. We'll bang up to 25. Save and calculate. And now we'll simulate. And as you see, she's come further up. And from that angle you can see it is following the surface. So even with a square tool, if I go into Solid Verify and run this again, we should see that we have a pretty good surface. Just say no to that, let it go. We'll zoom up. And you can see there's very little faceting in there. So we're coming up. We didn't finish that surface properly anyway, so that edge is now fixed. We can come round and by simply save and copy, in the geometry we can add new faces, which would be the faces on this side. Here, and our edge surfaces here, and drive surface offset we'll set to 0 here. That would explain some of the problems in the one before. In the gouge check, our faces here are again that face. Save and calculate, and let's have a look at this side. As you can see, I'm minimizing the amount of operations that I have to do. I'm only changing what I need to change, which makes for pretty quick programming as the experience builds. And you can see there we nice have this toolpath that will clean up that edge. So let's go back in here. I think I left 0.25 on that. I did. That would explain some of it. And let's go down to the toolpath parameters and put this down to 0.2, 0.2. Save and calculate. Now all of this has been with a male path. After I've done the simulation on this, we'll flip over and have a look at the other side. We'll simulate this, and we'll use the quick Solid Verify, and I'm going to use turbo mode here. If I click every now and again with turbo mode, it will jump forward. It just saves the graphics being used. Now on to the next tool. Now if we look in at it, it's still a wee bit rough, but you can see that we have our shape with nice clean edges in at the side there. So that's how you can tackle odd shapes like that. So I'm going to close this one down and quickly move her over onto this one. Now this is just a simple shape. It's, as I say, it's the other one. I'm only going to have one quick toolpath on this. We go SolidCAM, new, milling, choose our method of storage. In this case I'm leaving it as external. Say OK. I haven't created a stock. I'm just going to define the top of this as my top center as my datum. Say OK to that. Levels are OK. I'm quite happy with them. OK again. And let's just choose, and we'll add a little bit of stock on. Our solid here is already chosen, so we'll put on 0.15 on all the sides and 2 on the bottom. Pick my solid now and you can see that that has been added round about it. I'm not going to add it to the model. In this case I'm just going to say OK. My target is already defined because it's the only solid in there. My post processor is already picked. In this case I'm going to use the 6mm ball end. I'm going to take several roughing cuts and then finish it in 2 operations. So I'm going to add a milling operation HSS. The geometry we're going to pick, the drive surfaces here, are these same surfaces. Now we'll be working on the inside of them. As you see, there are still small areas that need to be picked individually, and there's actually one in there as well. So this just helps the continuity of the surface. Now that's fine. The tool I'm going to pick here, as I said, is going to be say 6mm ball end. We'll just leave everything else as it is. We'll leave this as parallel cuts. Geometry, we'll define the angle by 90. I'm going to leave on the surface 1mm, and then my roughing and more, I'm going to choose depth cuts, and I'm going to put 5 cuts at 3. Whole path, we're going to sort it by passes. Save and calculate. Simulate this quickly just to see where the path is going, and you'll see that the first time there it ran the whole path but only touched at one point. So while there is a roughing capability here, it's probably best to use the HSR module to rough it down first. Anyway, we'll take 1 off of that. Depth cuts, we'll make it 4. Okay, save and calculate. Now we're going to go on to the next one. The choice this time is going to be parallel to curve, where we're going to pick one of the outside curves. We'll choose that curve there. So the whole toolpath will be formed in line with that. So geometry, tool, we'll start and end at the exact surface edges. Everything else is picked. We switch off the roughing. Okay, and on the gouge check we will simply select the drive surfaces and we'll trim and relink the toolpath. Now for speed I haven't changed the step over here, so we'll see how this looks. If anybody's got any questions, if they'd like to put them in just now before we finish, we'll have a look at it now. Can you see what's happened here? This has went perpendicular to the curve, so at all points along here it will always be perpendicular to this control curve. The two methods that are available are perpendicular to curve and parallel to curve. Both, one works along the curve and one works perpendicular to it. In this case, where drive's offset, we're going to set down to 0, which I forgot to do, and we'll go down to 0.3. Save and calculate. As you see, there's a number of different ways that you can look at this and take advantage of the facilities that are supplied. Right, now let's look at that toolpath again. Actually, I'll be honest, that wasn't the one that I was looking for. I was looking for the other one. But in actual fact, this is probably the one that we wanted to use anyway. As you can see, it's kept that nice sort of constant step over as it goes round about. We'll run the solid verify. These areas where it looks as if it's gouged, let's find out if it actually has. One of the things that we can do here is we can run the solid verify, and then we can check to see the difference between the theoretical and the actual finish. Now I'm just going to run it in turbo mode so it goes through quickly. It'll take a few seconds to do that. Usually if you click the mouse it jumps forward. No, we're not too bad. There are a couple of areas there that need tidied up, tightened up. But for the most part, now we can use this option here with the 3 stripes, or again compare target and model. And if I execute this, you can see by the colouring here how close to the theoretical surface we are. Now red would be below 0.1, so it's a little bit of gouging in there. The amber is within 10 microns of 0, and the yellow is on 0. So that little tool there gives you a check to see if your toolpath's misbehaving. Okay, so it may be that I want to do that the other way. So all I'm going to do here is parallel to curve, and in my geometry, oops, it's already picked. We'll pick that curve again, just so that we go through the process. Save and calculate. And let's look at the simulation. Now you'll see this time that the toolpath is behaving differently. It's come parallel to that edge surface and followed that right the way around. You can even see it the way that the path is following in here. With the morph, it would have finished off on this side as it parallel to the curve as it did on that side. However, that looks fine. So that's a little taste for the capabilities of HSS. We could go in and choose any individual surface and machine that on its own. If that surface had come out badly, let's take a small cutter, say a 2mm ball nose. Not bothered about anything else again, we'll just pick it. Geometry, let's pick our drive surface here. And we will pick, this time, morph between two adjacent surfaces, and in my geometry I can choose my start edge surface, which would be this one, and my end edge surface, which would be this one. Choose my tools already chosen, toolpath parameters, we'll go down to 0.15 here. Gouge check, we'll just pick the check surfaces. In this case again we'll just pick them. We can see all faces adjacent to, and that'll do fine, picks up those two. Save and calculate. This is especially good if you've got a part that's been machined before, maybe a tool where one particular piece requires a bit of tidying up. It's maybe been built up with spray metal and needs taken back to shape. Using this facility, the fact that we can go in onto one single surface, then you can go in there and clean it up without any problems. Now, as I say, if you have any questions, if you'd like to put them just now, we'll have a look at that before we finish. Okay. As you can see now, we have simply worked only on that one surface. Let's look at the solid verification on it. Okay, no questions, so I'm going to leave it at that for today. Thank you very much for joining us, and look forward to giving you another presentation in a month's time on 2D iMachining, and then later the same day on 3D iMachining. So this is Ronnie Smart saying thanks very much, and we'll speak to you again. Goodbye.